All right, welcome back. We are going to start today the conversation about simplifying rational expressions. This little bit that we're beginning with is 100% review, but hey, let's do it. So I'm going to write an expression here for you. And I would like you to pause me for a minute and take the time to simplify this expression. This is a rational expression. Rational means it's in the form of a fraction, it's a ratio. And so, again, pause me, take a minute, and simplify this guy. All right, here goes. 40 and 12 have a common factor. I'm going with 4. So the 40 will reduce to 10, and the 12 will reduce to 3. Now what we're going to use here is our subtraction rule for exponents. So when I'm looking at my m's, I should have an m to the third in the denominator, an n to the second in the numerator, and a p to the fifth in the denominator, and that guy has been simplified. Now again, there's absolutely nothing new there. That's all stuff that you've learned previously, but that is an example of simplifying a rational expression. I'd like to move on to some rational expressions that require a little more effort, probably in the form of factoring. So here is an expression. Now, my goal here is to factor and hopefully, potentially, find pairs of common factors, one of which would be in the numerator and one in the denominator, so that I can eliminate that common factor and simplify this expression. Now, that doesn't always happen, but the only way to find out is to factor to see if there are in fact common factors. So I'll go ahead and factor this guy. Let's see, I need numbers that multiply to negative 21 and add to negative 4. So I'm looking at x minus 7 times x plus 3. And then in the denominator, multiplies to negative 35 and adds to negative 2. And that's going to be x minus 7 and x plus 5. So I've factored my rational expression, and now I'm looking at this thing and I can see that there is a common factor here. The entire factor has to be in common. You can't take pieces of binomials or trinomials. You have to take entire factors. So these two factors cancel one another out, leaving me with x plus 3 in the numerator and x plus 5 in the denominator. Again, you cannot touch those x's. They are parts of binomials, and you can only cancel out entire binomials. Now, we talked earlier this year about the fact that when you have expressions that are fractions and the denominators contain variables, that you need to talk about the restrictions on the denominator, because denominators of fractions are not allowed to be 0. That would make the expression undefined. So this is my simplified rational expression. However, I'm now going to take a moment and say, well, wait a minute, x cannot be negative 5 is a restriction that I have. And so here is my simplified rational expression and the restriction on the denominator. All right, you guys, do this one. So again, you're going to pause me, factor, see if there's any common factors, simplify, and restrict the denominator of the expression. Alright, so we factored the numerator with a common factor of 4x, factored the denominator. There is a common factor of x minus 8, so it's eliminated, and I have my new simplified expression with the restriction on the denominator. Try these next two. I'll write them down. You can go ahead and pause the video, simplify the expressions, and then start the video back up again and make sure that you are on the right track. 2 for you to do. Go ahead and pause me now. Okay, so again, we are factoring using whatever method necessary so that we can identify if there are any common factors that can be eliminated. Again, sometimes you can eliminate, sometimes you can't. We have examples here where we could. And then you want to make sure that you pay attention to the restriction on the remaining denominator. So once you have finished taking notes on this video, you are going to get the Simplifying Rational Expressions worksheet and complete that.